Hi, so we'll be seeing the routing of a message from this one network to another network, which is this is our target network. So the sender in network A is lying, and it has to send a packet to the host which is lying in network B. Okay, so first of all, let me uh, teach you about this network. So this is your host in network A, and this network has this IP CIDR, okay, 192.168.1.0/24. So, and this is a CIDR notation of IP. Uh, I hope you all know about this. So, there is the 32-bit address for IP, and from 32, since there is 24 mentioned, that means 24 bits are already reserved, you cannot change them. And from the remaining 8 bits, you can form any number. So 2 raised to power 8, that is 256 numbers you can make from 0 to 255. Okay, that means you can assign 256 host IPs from using this CIDR. Okay, so therefore, as you can see here, I have assigned an IP to the host A, that is 192.168.1.1. So I have simply put 1 here in the available 8 bits. So that is the IP that I have given to host A. And what is the dot Ethernet 0? It is simply it is simply represents the interface. Okay, so this is your host, and this host has an NIC card attached to it. Okay, this is an NIC card. So as you can see here, this is a router, and this router has multiple NIC cards attached to it. R1 dot ETH1, R1. So this is R1 dot ETH to ETH0, and similarly this is R1 dot Ethernet 2. Okay, so these are the multiple NICs attached to router 1. So similarly, these NIC, so the router is a part of network A and network C, and it is a part of this another network, that is the transit network. Okay, so this network is basically the network formed between two routers. Okay, as you can see here, there are router 1 and router 2. This is a router 2, and so these two routers with each other form a different network, which is called transit network. So therefore, the router 1 is a part of three networks: network A, network C, and the transit network. Okay, so from network A, it gets an IP, and from network C, it gets an IP, and from transit network also it gets an IP. So similarly, as you can see, there is a CIDR given to network A. There is a CIDR given to transit network also. So from transit network CIDR, we have picked one IP address and give it to R1 dot Ethernet 2. And similarly, from the CIDR, we have picked another IP and given to R2 dot Ethernet 0. So as you can see here, R1. So from transit network, these are the two IPs, R1 dot Ethernet 2. So we have, so these, so as you can see here, dot 1 and dot 2. So these are the two IPs that we have taken from transit network and given to the routers R1 and R2. And similarly, we have also, as you can see, there is a host B. We have also given one IP from this CIDR to the host B. Okay, so now let's see how the packet will be transmitted across the network. The packet will hop from one router to another and ultimately reach to the destination. So let's see how will that happen. So let me teach you that step by step. So first step will be uh, host A sends the packet to router 1, but router 1 is a part of three networks. Okay, as I already mentioned, part of network A, C, and transit network. So there are three IPs that are given to router 1, R1.Ethernet 0 and R1.Ethernet 1 and R1.Ethernet 2, because it is a part of 3 network. And similarly, it has 3 MAC addresses also, because there are 3 NICs attached to it. Each NIC is serving the purpose of receiving traffic from each of the network. So, so now A will send the packet to R1 dot Ethernet 0. Okay, because they are in the same network. So now how A will send it? So first of all, A will make an ARP request to R1 dot Ethernet 0 to ask for its MAC address. To ask for its MAC address. Okay. So suppose A has received it. So now A will prepare a packet in which it will mention its own IP. So A's IP is this 192.168.1.1, and now the destination IP. So destination IP will always remain the IP of B. Okay, and B's IP, as you can see here, it is 172.16.0.1. Okay, and now the source MAC address. So source is our A. So here you can see A dot Ethernet 0. This is the source MAC address, and the destination MAC address is the router's MAC address. Okay, R1 dot Ethernet 0. Okay, this is the R1's MAC address. So now this packet will go from network A to router 1 dot Ethernet 0, and router 1 will accept the packet because the destination MAC address is the router's MAC address, so it will accept it. Now second step, R1 receives the packet from A and checks its routing table. So now as you can see here, there is a dilemma at router 1. Okay, which dilemma? So where to send the packet? It may have to send the packet back. It may have to send the packet to network C, or it can send the packet to this link, over this link R1 dot Ethernet 2. So we say that there are three interfaces. Okay, one interface is this, second is this, and the third one is this. So through which interface it must send the packet. So router maintains a routing table with itself. So for example, let's see the routing table of R1 router. As you can see here, the destination network is 192 something. So this is your destination network. Okay, if the packet that router receives, if the destination IP belongs to this network, then it will send through R1 dot Ethernet 0. So from this interface, the router will send the packet. Okay, but if the destination is 10.0.0, so where is this? This is this network C. Then let me mention also, this is a network C, this is network A, and 172, as you can see here, it is network B, and 157 is network D. So if the so let's come to second. If the destination network is C, then it will send the packet through R1 dot Ethernet 1 interface, through this interface. And if the destination network is either this B or D, okay, as you can see, B is here and D is here. So it will send, so the decision is being made at router 1. Router will send through R1 dot Ethernet 2 from this interface. As you can see here, the interface is R2 dot so this is, sorry, I mentioned it wrong. This is one should be R1 dot Ethernet 2. So this is R1 dot Ethernet 2 from this. So now let's see our scenario. So R1 received this packet, okay, and now in this packet you can see the destination IP is what, 172 something. So where is this 172? 172 is the B network. And now let's check the routing table. So when the destination IP is of network B, it will send to the next through r1.ethernet 2. So first of all, one thing is confirmed. So it will not go from there, not go from there. It will send through here. Okay, from this link. And now where it will send? It will send to r2.ethernet 0. So now there is a router. Okay, this is r2. Now r2, now since from here the packet will leave from r1.ethernet 2 and it will go to this IP. Okay, so it has to know the MAC address of this NIC r2.ethernet 0. So now it will also make a ARP request r1 dot ethernet 2 makes ARP request to r2 dot ethernet 0 to get its MAC address. Okay, so once it's received the MAC address, it will prepare a packet at itself. So in which the source IP now will be the so the source IP will be r1.ethernet2. So what is the source IP now? 120.16.0.1. Now 120.16.0.1. Uh, so as you can see here, this is your source IP now, and destination IP will remain always the target ultimate destination 16.0.1, that is B's IP, and the source MAC address will be the r1 dot ethernet 2. So as you can see here, the packet is leaving from this interface. Okay, from this interface. So this is r1 dot ethernet 2. So hence the source IP, source MAC, this is now the source MAC, and the target MAC will be r2 dot ethernet 0. And from where did this MAC address, from where the r1 get this MAC address? From ARP request. Okay, and now the third step, now who receives this? Now since the packet has traveled from this path and is received by the router 2's ethernet 0. Okay, so now let's see how the packet will be processed at router 2. So router 2 dot ethernet 0 will receive from where? r1 dot ethernet 2, and check its routing table. So as you can see here, what is the destination IP? 172. This is the destination IP. So this packet is received by R2. So destination IP is 172. So as you can see here in the R2's routing table, the destination table, this matches the packet that R2 received. So this packet is received by R2. Packet received by R2. Okay, and in this packet you can see the destination IP is 172, and from the routing table of R2, the 172 destination network interface is r2.ethernet 1. Okay, so as you can see here, so yeah, right, r2.ethernet 1. So now the packet won't go from here. Okay, it won't go back, it will go from this interface. Okay, so now let's see. So now again the problem will come when choosing the MAC address. So first of all, let's see how the packet will be prepared at R2. So it will mention its own IP. So what is the IP of R2? As you can see here, R2 dot ethernet. Okay, so now the packet will be sent by r2 dot ethernet 1. Okay, so let me mention it here, r2 dot ethernet 1's IP. So what will be its IP? Since now you can see r2 dot ethernet 1 is a part of network B. Okay, it is a part of network B. It is a part of network B. So it will get the IP from this CIDR, and it will get 172.16.0.2. Okay, so this is the R2 dot E 172.16.0.1. Sorry, 2. Yeah. So this is the R2 dot Ethernet. What was it? 1. And now the destination IP will remain same, 172.16.0.1. So this is the destination IP. And now the source MAC address. So this one will be the R2 dot Ethernet 1's MAC address. R2 will obviously know its own MAC address. Now here comes the MAC address of uh, destination. So now as you can see here, there is no hope mentioned here. Okay, as you can see here, no hope. That means there is no another router to which the message has to be transmitted. Okay, whenever there is no router's name mentioned, that so then it implies that the router and the destination are in same network. Okay, are in same network. So this is a law. As you can see here, when the packet is received by the R1, so when packet was received by R1, uh, it was not in the same network as the destination network. So destination network is B, whereas router 1 was a part of A, C and transit network. There was no B. Okay, therefore it had to send the packet to router 2. Okay, so, but now since router 2, as you can see, router 2 is a part of transit network, network B and network D. As you can see here, router 2 shares the NICs with three network. This is network B, network D and transit network. So now our R2's one NIC is in the same network as the destination network which is B. So now there is no hope mentioned here. Okay. Therefore now R2 will make ARP request to the destination host in network B. Okay, it will not make a ARP request to router. No ARP to router. Okay, because it does not want to know the MAC address of router. It wants to know the MAC address of destination host. So once R2 will get ARP reply from whom? From destination host, then it will use it here. Okay, now here the MAC address of destination host, which is B. Okay, so now finally so now finally at fourth step, host B will receive the packet, and as you can see, this packet is received by host B. So the MAC address is of B. So let me show you. This is a data link layer, network layer, transport layer, and application layer. So the packet comes from here. It will be converted to bits. And data link layer check the MAC address of host B. It passes, as you can see here, the MAC addresses of B. And from to network layer, it checks the IP of B. So the IP is also of B. And similarly it will check the port number here. So port number will be used to redirect the packet to which application. For example, a browser is running here, so the data will be passed to browser. Okay, data will be passed to browser. So this way the packet will reach host B. So so that's how the packet is transmitted across a network that contains multiple routers in the path. So each router will put its own IP and MAC address in the source part of the packet and transmits the packet to another router. And the last router will lie in the same network as the destination host. So it will simply unicast that packet to the host.